I'm C.K. Today we've got another one from Befaco. This is their Ilse. They market it as a beginner level synthesizer VCO. Looks like it might be pretty much fun, and it's Befaco, so it'll probably sound really great too. So we'll take a look at it, put it together, and see how it sounds. And I hope you enjoyed the video. Let's see what we've got in the bag. Maybe simple, but it does have a lot of parts, or maybe for beginners, but it does have a lot of parts. I'll take them all out of the bag. Let's get the front panel and circuit board out first. And let me cut it open, because as always, I'm terrible at packaging. Come on! And we've got, looks like an LFO at the top section, speed, filter mod, and oscillator mod. So I don't know if that's all LFO, but I don't know. Cutoff for the filter, oscillator 2 detune, oscillator 1, oscillator 2 flit in. Filter in? Maybe. Tuning, filter on the little kitty cat's ear, resonance, volume, filter in, cutoff. Is this, I thought it was a gate, out. I guess it's a filter. I thought it was a oscillator. I'll double check it when I look up. It's labeled from the Center for Haptic Audio Interaction Research. I think this is an open source project. And here we've got the circuit board. Now that is, it's interesting. Hold on one second, folks. Let me grab another Befaco module from over here. This is the Pony VCF I did a little while ago. Look at the difference here. I don't know who did this circuit board for them, but it's not Befaco's standard circuit board. It's obviously a more deeper maroon color. It's less glossy, and it's got relatively straight paths, which is unusual for a Befaco circuit board. But no worries there. Let's see, we don't have, the board looks good. I mean, obviously it's got through-hole plating, it's dual layer, it's got a bunch of stuff on it. The values aren't here, but that's okay. We've got a trim pot here for something, transistor, a couple of diodes, power coming in, 2 ICs, resistors, and I think that's a switch. And Ilse Rev 4 based on Totoro by Synth, open source hardware, and designed in Weimar, built by you. Let's see what we've got as parts. Okay, they include the Center for Haptic Audio Interaction Research sticker, CHAIR. And we've got the build guide to go look up. Should be relatively bare bones, as Befaco build guides tend to be. Bunch of resistors, 2 Chipmundos, which I will look up what they are in the interval. Let's see if we can see. There's a 074 op amp and another 074 op amp, so they're 2 op amps. A couple of diodes, that's all good. 104 decoupling caps, power connector, transistor, power supply, voltage regulator, a couple of foil caps. And in this mechanical bag, let's see what we got. Got one A taper 1 meg and one A taper 1 meg, so 2 of those. Then we've got think a bunch of 100K pots. I think they're all 100K. It's a lot of pots. This must be a filter. I must have read that wrong. We'll come back to it. And then, of course, another Befaco panel nut wrench. I think that makes 21 for me. And the knobs. Oh, look. Oh, no. I'm sorry. I got excited for a minute thinking they had a better pot on this kit. It's slightly better. It's harder plastic, but still no index, still no lock screw. Come on, Befaco. Get better knobs. Only complaint I ever have. Okay, so that looks pretty straightforward. And the board, if I look at it from a beginner's perspective, the only challenge I see is there's a lot. Look at this row of resistors. And there's a lot of close soldering. So that might be a challenge for a beginner. But altogether, it's a good little kit, looks like. So we'll get the soldering iron heated up and put this thing together. And I'll figure out what it actually is. I really thought I read that it was a synth. But that's okay. I can be wrong. I was right. It is a synthesizer. It's just the front panel components don't have a lot. I mean, they have other stuff in it. The synthesizer is pretty much what it is. And yeah, the circuit board is different because Befaco's Befaco is distributing this for them, but they didn't create it. So look through the build guide, which is a little more detailed than a typical Befaco because it's not from Befaco, it's from the people who designed the board. And looks good, no particular surprises. So we'll just dive in, and of course the first thing we'll dive into are all the resistors. And again, since I haven't done this circuit board in the past, I'll give it a check real quick to see how it holds solder or takes solder. And one thing to be very aware of, there are ferrite beads on this, which will go near the power near the power connector. And as you know, you want to save a couple of resistor leads for the two ferrite cores. I want to check these resistors. They're quarter watt resistors. I just want to see what their tolerance is. I'll try these 10Kers first. And they're not high, they're not the highest tolerance, but we'll see what it is. No, don't put it in a voltage, put it in an ohmage. 100K. Oh, I got the 100Ks. I didn't grab the 10Ks. Let me grab the 10Ks just so I don't confuse myself, because they come first in the build guide. 9.93. That's okay. Let's try one more. If I can get I'll do the other end instead of trying to do it in the middle, because I'm failing at that. 9.98. Oh no, the tolerance is very good. I have no complaints with that. So we'll pull all these fellas out. Just double checking. Oh man, that's dead on 10K. That's nice. Let me move the meter out of the way now. And we start with R1. Gets a 10K. And let's see how their layout is, how the numeric order. Befaco is real good about laying out theirs almost in sequential orders. Other people are not so good. And this one seems like it may be a little scattered around too, because I've got R12 up here by R9 and things are a little bit more scattered. I'm still trying, and R1 is right here in the center. Don't know what you're doing right here in the center, unless they numbered by spiraling from the center out. I don't think they did. I'm just trying to justify having resistor 1 in the center of the board. Give it a little solder. Oh yeah. Solder's up just fine. Now we've got about 40 more resistors to, we've got about 40 resistors to put on in total, and we've seen what one looks like, and the rest of them will all be similar. So as is typical, I will turn off the commentary track, speed up the playback, and probably cut a bunch out of it because there's not much more to learn or see, but it does give you a chance to enjoy resistor time. So that's resistor time for today. And again, don't try and make rhyme or reason out of positioning versus numbers. If you think, oh, since R12 is here, R13 must be close. No, it's not. It's way the heck over here. And so on. Just search around, and of course, each resistor you put on means one less place to look for the next one. So it's not quite the easiest, but it's okay. Now we're going to do the diodes, and we've got 3 polarity protection diodes. You usually only see 2, and there's one and there's the other. There's D1 and D2 near the power connector, which is where we usually see polarity protection diodes. And I'm looking for D3. Oh, there it is. It's under R31. Oh, here it is. I'm sorry. As I was looking, it was under the shadow of R31. I want to do the ferrite beads now. Let me show you what we're talking about here. So here's a little ferrite bead made out of iron ferrite material. And I saved 4 resistor leads, even though I only need 2, because I often lose at least one. And we put it through the center, and then bend it down on the sides just like a resistor. And then we'll put it through where it says FB1 and FB2 for ferrite bead 1 and ferrite bead 2. There's not a standard for circuit board marking for ferrite beads, so it could be always just check your instruction or bill of materials to see how they labeled it on the particular kit you might be working on. Ferrite beads just add a little more smoothing to your power. Now we're going to put the 2 op-amp chip sockets on. And there are the IC sockets. Now we're going to move on to the next bag, which has has all the capacitors and some other stuff, including the power connector. But first we'll do the 100 nanofarad to 104 caps, decoupling caps for the ICs. And as you can see, I'm not trying to pull them free of the paper tape. I'm cutting them out of the paper tape, because if you try to pull them out, you can do it, but you'll often mess up the legs, and it's just a pain So C4, C8, C10, and C11, and as I said, they should be near the ICs. And then we've got 220, 200 or 22 picofarads at C14. Now we'll do the electrolytic caps. I think they're both the same. They're both 10 microfarad. And we're going to double check that. Yep. Yep. And they go here and here, and there are clear markings as to where the long lead, the positive lead, goes, and where the striped side, the shaded side, goes. So that should be easy to get correct. Now he wants us to do the power connector at this point. Okay, I'm fine with that. Before we do the other film capacitors. Now, it's a keyed power connector. You can see the little key, and there's a little notch in the circuit board telling you where it goes. There's also a stripe, so you can see which side the red stripe should be near. So just to make sure that everything is correct, we'll take an actual power cord, put it in there with the keying right, and it shows that the red stripe is going with the stripe on the circuit board. So we're all good there. And I am going to just, for this one, I'm going, because the board's not completely flat on my solder pad anymore, I'm going to solder one leg, and oh, it's pretty flat, but just to be sure, I'll press on it with my thumb, reheat that solder, and it is completely flat. And yes, for those who wonder when I'm doing that, how I don't burn my thumb, well, the reality is I do burn my thumb. I just have done it so many hundreds of times. I've burnt my fingers soldering so many hundreds of times that I don't notice, really. I don't react. Nerve endings are all dead. Okay, so the power connector's on. I'm going to not trim those leads right this second because I'm going to go ahead and put the film caps on now, and we've got 4, 1, 22, it all looks good. Now we're going to do the transistors. So these are our 3904s. Now we'll solder everything we've put on. And I think we only have one, because it's a single layer board, single board. And that's the jumper, which will be setting here at JP1. And they say to put the shorting pin on the header right now to make sure the gate on the transistor is always open. And now one trimmer, which I believe sets the volt per octave range. And that is all that we're going to be soldering on this side. So for a sanity check, I'm going to go through, take my card again, make sure we've got all the component positions filled. And now what the author of the kit would like to do is have us do a sanity check before we do anything else, just to make sure everything's working right. So I got my little benchtop power supply and I got my meter. So we're going to fire this fella up. I don't want to use that one because I'm going to be getting at it from the front. We'll put that one in. Now it's powered on. The ICs, of course, are not in there yet. So we're going to go to ground here at this nice little ground point where one of the legs to the pots is going to be. And then we're going to go to pin 4 here. Let me not cover up the meter so you can see what I'm doing. 1, 2, 3, 4. And we got 12 volts, which is great. And on the other side we got minus 12, 11.9, that's fine. Let's try it on this socket. We've got 12 there, and once again 11.9. So we're all okay, so we can disconnect this. And I'll unplug my little power supply and put that away for now. Watch how slowly that LED fades away. These 6 big caps, there's nothing, it's not plugged in. It's just holding, those 6 big caps are holding a lot of charge. And you can see the LED slowly fading away. That's why you're always careful with things with large capacitors in them. Now, he wants to put the op amps in right now, and he's calling them 072s, they're 074s. They wouldn't, if they were TL072s, they wouldn't take this big a socket. These are TL074s, so ignore what that says. Now we're going to put all the front panel components on, and of course we're not soldering them right now. Now we're going to do all the 100K pots, place all those, not the sockets. I always do, you know, I know most people do this, but I want to mention why. I always put the potentiometers on before I put the sockets on, because these little bends in the support legs that keep things locked into place, they also cause the circuit board to bounce a little bit when you click them through. And if you've got the jacks on, then they will click against the jacks. I mean, they will bounce the jacks out of their position. I've done that. I should have done the middle one first. I'll do the middle one first. So you should always be putting the potentiometers on first. And the only thing we have to make sure of here is we want to make sure that we don't have any connection. Yeah, we're not interfering with anything else. And now this is RV2. We're going to be looking here to see, and I'm going to get brighter light in here. Where is, I'll use my phone. We want to make sure that the little stands on the back are not touching any of the solder pads, because we'll be grounding that component, and that would be bad. I don't really like the way that's going. The only one I'm at all worried about is this one at RV10. So I'm going to get a pair of pliers, my carbide cutting pliers, my carbide jawed cutters. And I'm just going to trim a little bit of this off. So I know it's not going to hit any of the legs of that transistor. And I did not put as I said, I did not put the ICs in because I don't like to put the ICs in when I'm still manipulating the board around, because I don't want any stray static discharge or me just being ham-handed and bumping up against the chips, potentially disrupting them. So there's all those bits. Now it's interesting, we do have this grouping here of stuff, of sockets. When we turn this over, we'll take a look at that. But the next thing we're going to do is turn off the light on my phone. And we're going to drop the LED in. Where did it go? There it is. And there's a nice plus sign on the circuit board to tell you how to put it in. Now that all looks reasonably good. Going to drop the front panel on. Oops, and of course one of the jacks came out, because that's what jacks like to do. They like to jump out. Making sure all these are seated right. Oh, that went on very nicely. So what I'm going to do is grab my little clamp the board together so it's all flat and nice. Take a look at everything, make sure everything is fitting securely and flat on the board. And what I like to do is I will solder this one jack down here on this side. And then I guess I'll do this pot right here. And now I'm going to remember which one I did, which I often forget. I'm going to put one panel nut on the one I soldered down. And then put a bigger one on the potentiometer I soldered down. Get my little Befaco panel nut wrench. Oops, turn it the correct way around. Snug that down. Snug this one down. Now I can get rid of the clamp, because now it's just holding together with those two thingies. So I'm going to get some thick solder for the support legs of all the potentiometers. You don't have to do that, I just do it because I use a bunch of solder. I'm going to do all the support legs on the pots. Actually, I'm going to be soldering all the components, so again, we'll speed this up and turn the sound down. So that's all of them, I think. I'm going to double check here. And as I don't know if I cut it out, I won't know if I cut it out or not, but there are a couple of challenging parts here. These three leads are real close to these resistors, so just be careful. Same thing here, and this is right up against the power connector. And this looks like a external connector to be able to send our volts per octave CV, our LFO speed, and other things in through another connector that we don't have, probably another type of module. So that's all good. Now we'll put the LED through the front seat. That's all sticking out. It's the LFO rate LED, and I don't want it sticking through the panel. I want it to be flush with the panel. So I'm going to take a little piece of painter's tape, which I always have handy. Take a piece of it like that and put it against the top of the LED, so it's going to be flush against the panel, not sticking through the panel. That's just a personal preference. If you want it sticking out so maybe you can see it from the side better or something like that, that's certainly reasonable. I just like it this way. Now we can clip those leads off. And pull the painter's tape off, and as you can see, it's nice and flush with the front panel. Now I'm going to put all the panel nuts on, and again, sound off in fast motion. Now we'll put the knobs on. Now we do have one panel nut left. We have a red panel nut, which is typical on a Befaco board, will be the out. But in this case, they had a silver panel nut, and I chose to put that in as the out on this. Just so I know, if nobody else cares or sees it ever, I know this is not. This is distributed by Befaco, but it wasn't made by them. Now we can put the ICs in their sockets. Make sure the notch on the IC is matched up with the notch on the socket, which is matched up with the notch marking on the board. And these are really close to these foil caps. But that one went in without bending anything. Do the other one. So yeah, these TL074 have 4 op amps inside. 072 has 2 op amps inside. They're different sizes. That's why I was kind of surprised he had the wrong. We'll go ahead and calibrate it. Let me get my other little power supply out. You'll see in a second as I set things up. Now we're going to set the octave tracking. And what we've got here is, I've got the wrong screwdriver. Let me get the correct screwdriver. We've got the Ilse here, as you can see. The LFO is operational. You can see it flash. I don't have anything coming out of it. I'm turning it all the way down. I've got my Voltio, which I built last week, a couple of videos ago. This is a reference voltage source from Befaco, and I use it to do things like this to make sure I've got exactly the voltage I want going in and the right. As I flick this, each change is 1 volt, so that's 1 octave. There's my power supply and a little speaker for my little amp, so I'll turn that up. And again, we don't care about the tuning right now, because right now I've got the knob set, so it's at about C5, as you can probably see here. Now, if I change this up 1 volt, it should go up to C6. It just drifted for some reason. It's drifting back. I'm going to get it right back to C5. Now go up 1 volt, and that's B5. So I want to go up a little higher on that. Okay, I'm going to live with that. Let me go all the way down to C2. That's C3, sharp a little bit, but I'm going to live with that. Again, we don't get into eurorack to make things exact. This is going to be good enough for me. So I'm going to disassemble all this, put this in the rack, and we'll see how it sounds with a real sequence going into it. Alright, let's try it in the rack now with a real sequence going. I've got the sequencer set to very slow, so we'll just listen to a single tone first. Okay, let me change some things. Cutoff's wide open. I've got OSC2 detune in the center, and you can hear as I change it, you can still hear the bass oscillator, oscillator 1, and you can phase them against each other. Let me move the note a little bit. You can hear that, can't you? Change the tune. Might be able to hear the two better this way. There, now they're almost in sync, which is not quite straight up, but again, I didn't calibrate that, so I'm not too worried about that. So let me go ahead and turn the sequencer up some. Let me turn it way up, actually. That's a normal sounding thing. LFO's down, resonance is down, volume's pretty much all the way up. I'm going to change oscillator 1. That's oscillator 1. That's oscillator 2, as you can tell, and that's a mix. There, you hear that almost chorusiness? I like that. Let's try some resonance. And I'll drop the cutoff down. Again, this is all within this, the synthesizer, so it's not going to any external filters or anything like that. Now I'm going to put in some LFO, and I'll do that to filter mod. Now I'll take it out of filter mod and put it into oscillator mod. Don't particularly care for that, but you might want to use it. I'm trying to make sure I'm getting the right signal here. Yeah, I am. Okay, so we'll try, and again, you can adjust the tuning. Now I'm going to put an LFO into cutoff. Now I'm going to put that into filter in. I don't think that's what that's for. That's to put an external signal into the filter. Put it in gate. I don't know what this could do. Actually, let me put a straight pulse wave into that gate instead of a triangle wave. If I could find the end of the cable. Where's the end of the cable? There it is. That's with a relatively fast pulse in to the gate. You can figure out ways to use that for sure. Let me put this back in cutoff, and then I'll see what the knob does. So the knob, cutoff knob is still active while the cutoff CV is also active. And let me try the built-in LFO. Now we got all kinds of modification. Now if I take that, this allows me with the external LFO, I can do the filter cutoff without having to use that, and I can use the built-in LFO for the oscillator mod. Gonna take that back out. So as you can see, it's got quite a bit going for it. Let me set it back down to reasonably normal. Try and match the two oscs. So that's what it does. It's a competent little full synthesizer with interesting features. As you saw, it's a pretty straightforward build, even though I would not say it is a first build, because there are so many connections that are very close together. I might say second or third build for this one. But it is a fine piece of stuff from the Center for Haptic Audio Interaction Research, distributed by Befaco. And I hope you enjoyed the video.